All right, everyone. Welcome to this little Onshape workshop for mentors and or I guess anyone who's experienced but not quite with Onshape. I decided to put this workshop together because there are a few key differences between Onshape and other CAD programs, particularly in the mates, but you don't really need to go into as much detail for the creation of parts. So I figured just a rough workshop to go over some of the key features would be good. Also, based on what everyone has told me from the group of mentors, it seems as though there are some common areas where students made mistakes. So I'd like to go over a few places where students can maybe save some time or where students might commonly make mistakes. I don't know if I'm going to catch all of those instances because some of you mentors may have worked with those students more closely than I last season on CAD. So please bear with me here, and I'm happy to add additional footage of these features as needed. So for now, I just want to highlight that you're going to be working out of this CAD fish. That's what we're going to be working on today. And I want you to go ahead and create a copy for yourself. So you're going to click over here on the document menu and you're going to say copy workspace, or you can say rename document if you'd prefer that, and then just make your own copy of it. So you're going to copy workspace, and I'm going to call mine CADfish TAM. So again, the reason that I'm having you copy this is because if you are a mentor watching this workshop, then you already have experience making parts. That's not really going to be where you struggle to adjust to Onshape. And there's a lot of aspects of making parts that kind of carry over from SolidWorks and other programs. The assembly and some of the drawing features are going to be where I think our students are going to struggle, but there are still some features of this that would be useful for you to know. So with that in mind, I want to highlight one thing really quickly. You'll notice that a lot of the features are in these little subfolders here. So if you want to see everything in them, you can right click on the folder and say unpack. And if you want to make sure everything is still in a folder, then you can click on everything. Note that I'm not holding down the Alt key and that as I click, the number of things that I have clicked on appear next to my mouse, up to 5. And then you can right click it and say add selection to folder. And I am going to go ahead and just keep everything in a folder for now. I have a lot of different features here and I've deleted a bunch of features, and I figured that's probably a bit better than having everything out loose willy-nilly for your training. Another thing I'm going to point you to are part 1, part 2, part 3, and part 4. I'm going to go ahead and rename them fish body. And another way to rename them is to right click it and go into the properties. And from there, you can rename it to other things. And you'll notice that there's also description, part number, revision, state, which in this case, I'm unable to change, product line, all these other things, not revision managed, exclude from BOM. And I'm going to go ahead and recommend that we have students at least work on these top 3 right here. For one thing, if you're going to have multiple parts in a studio, it helps to know what's what. And part number, I mean, we can talk about this as mentors. On one end, I don't want students to get too caught up with making sure that there is a number and that we're referring to the number. But on the other end, I have seen years and I have seen projects where there's a lot of colloquial names that sound really similar. And the one real way to distinguish it is to give them completely unique part numbers. So that is something to discuss, but I really want them to focus on this description where they can say maybe fish tongue to be made of aluminum, finalized on whatever date. You know, some sort of notes so that if someone wants to know what a part is, they can see the function in here, who's working on it, what it's intended to be made out of, and, you know, go like that. Yeah, so that is pretty much most of what I wanted to show you in this side of the menu. So we're going to start on the fisheye. So I'm going to go here and notice that there's this nice little view cube over here, and that if I want to change views, I can also go here to change the views, also to zoom to fit, shaded, hidden lines, section view, so on and so forth. But yeah, let's start on this fisheye. And I'm going to start, as we always do, with sketch. I'm going to click on this, and we're going to have a really small eye. Ah, wait a minute. I just remember that a lot of the dimensions of this eye are going to be revolving around 1/8 of an inch or 1/16 of an inch. Let's see if we can speed things along with that. So a lot of features over here, and they're not all labeled. A lot of them look really similar to each other. And especially if you have a different aspect ratio, a lot more of them get condensed, yeah? So you're going to go over here to the plane drop down. In my case, I have that no matter what. And I'm going to select variable. And this does exactly what it sounds like. You can create a variable. I'm going to call it eyeball. And I'm going to have that value be, let's call it 0.125 inches. And now, and also notice you can use length, angle, number, or any. So just keep an eye on that. That'll be relevant later. Now, let's say I might want to change eyeball later on, or maybe there's a version of this that's going to have a bigger eyeball. I can right click here and I can say, hold on, I need to go to the configuration panel first. And I need to configure the Part Studio. So now I can right click eyeball and I can double click there, edit, and I can configure that value. And now that gets added over here. So I can create over here a new value. Let me call it big eyes. And I can make that say 0.15 inches. You know, it's pretty standard stuff. Just remember that if you want to configure the feature versus you want to configure a dimension of the feature, you're going to have to click on the dimension itself. And you're also going to, I don't think you need to start off by clicking configure, but it's just something I like to do before I actually start configuring. So yeah, you may need to do that. Anyways, oh, one more thing. You can also have the variables in this tree over here, as well as some custom tables and the appearances. Just figured I should go over those. So let's actually start on this eye now. Sorry for that tangent. All right, so where were we? Right, eyeball. So I'm going to start off by creating a little bracket thing that our eyeball is actually going to sit on, because this is a CAD fish after all. It's not your typical fish. So I'll just make a circle out here because, you know, students might forget to snap to lines, or maybe you decide you don't want to have a snap line. Speaking of which, I'm just going to make that wonky. I'm just going to, you know, go whatever which way I feel like, go whatever way I please. Hold on. Be careful there. I think I created a tangent. I don't want it to be tangent. Yeah, let's just do that, you know, a rectangle. So as you can see, lots of problems. And one thing I did notice some of the students running into in some of the CAD workshops is they tried to hard dimension everything without thinking of relations that could be used in its place. So what I'm going to recommend is, at least to students, obviously, you guys are more experienced at CAD than I am, but what I've been recommending to students is that they set their relations first, and then they set their dimensions, and that they also create construction lines as needed. So let's do that. Relations are all going to be in this drop down over here. So I'm going to click on the vertical one. Oh, and notice these letters right here. So they can be hotkeys if you're used to using those. Okay, here we go. Those are vertical. All right, let's make sure that they're not tangent, because every now and then, nope, not tangent. Perfect. All right, so now we go horizontal. And let's also make those two vertical lines equal to each other. There we go. Oh, and actually, you know, let's make the top line equal to them as well. There we go. That's a nice, cute little tab. But we are going to need to put a bolt through it. So what we're going to do is start off by creating a center line. That way we can mirror this tab over. So I'll start here, drag out, and then go through. And I hope you noticed I clicked on this line as I was doing it, construction. This will make the line for construction only, and you can kind of toggle it back and forth if you want. So if I click here, I click on construction, it undoes it. So remember to keep an eye on that. So now I'm going to show you how to use variables. So let's say I want this circle to be twice the size of whatever hashtag eyeball is. I type in hashtag eyeball, and now that's 0.125. You can also say 2 times hashtag eyeball, and now it's 0.25. I can probably go a little bit smaller than that, so I'm going to recommend a good 1.5 times eyeball. No bigger than that. Eyeball's not going to be very big. I will, however, drag this down a little bit because it's getting to be a bit high. All right, sure, that works. And now I'll make this hashtag eyeball as well and see if that's too big. It's a bit chunky. So I guess I'll go 0.75 times eye, or like, yeah, 0.75 times eyeball. We do need to put a screw through it eventually. So that is kind of an important dimension to have. And one last thing I'll do is I'll dimension its height. So what we're going to do is we're going to click on, I guess what's relevant to me is the center of this. Let's go center to center. And let's go center to center. Ah, no, let me go the other way. Yeah, every now and then it's going to do this. So be a bit careful about what direction you go in or about what dimensions you select. You can also select that horizontal plane. So I'm going to do 0.05. It's a bit high, but you know what? This is not a realistic catfish. This is a cadfish. There's mentor character to this. So we're going to mirror this. You need to select your mirror line first here. One difference from SolidWorks is a lot of times the messages show up over here or they show up in a small window in the corner. They're not going to show up as a separate pop-up. And I'll mirror this 3 lines. And now I'm going to snip these excess curves. All right. Now, one quick thing, let's say you're curious about the length of this line because you forgot that you added an equal distance, an equal length relation. Here's what we're going to do. We're going to go over here. We're going to click on show measure details. And now we're going to click on this line. It tells you. Now, let's say I don't want that line. I want this curve. Now it's also telling you the distance. Because remember, in Onshape, you can click on multiple things without holding down the Alt key and it will select them all. So be very careful about how you're clicking. This is a mistake I make all the time because after having dealt with a few different CAD softwares, I don't think I've ever encountered that specific feature of it. And I have a feeling that there are going to be students who make that mistake as well, particularly students who are used to SolidWorks. So with that, I'm going to X out of here. And I'm going to show you one other thing about making parts that might confuse some students. You know, I'll add the eyeball first, because that is the whole point of why we're here, isn't it? Okay, so dimension that, and I hope you remember to hashtag eyeball. And there you go. So let's extrude. And I'm going to select this outer one for now. So are we going to make a new or are we going to add? Well, if we add it, oh my God, that is way too big. Well, we're going to, dial it down a little bit. There we go, a nice flat plate. Nicely done. So well, we can go flatter. There we go, nice and flat. So we could do add, and then it'll just become joined with the fish body, but that's not quite what we want. What we want is a nice, robust frame that gets attached, right? So what we're going to do is we're going to say new. Okay. You know what? Now let's make it new. So that's what we're going to do. It's going to create a new part down here, part 5. Notice that it's folded now. And we'll say, okay, great. So now you have a fisheye. It kind of reminds me of the Clockwork Orange. I think it's because it's orange and there's like stuff going around the eye. My mind goes on tangents. All right, so now we're going to extrude one more time. And this time we are going to, again, we'll do new and we'll show the sketch and we'll extrude that eye by 0.125. Because if you've ever seen a cadfish, which unfortunately I've only seen pictures of, they do have kind of bulgy eyes. They're like, they're sticking out. They've got personality. And yeah, that's what we've done here is we've created a nice little fisheye. So because this plate is separate from the rest of the body, we need to actually bolt this into the fish body. Sorry, fish. So to do that, we do need to establish points on the sketch. And then from there, we need to use the hole tool. So I'm going to go back to this sketch and I'm going to right click and say edits. If I want to go head on, I'll say front and then I'll zoom in. So for now, I'm going to create our beloved construction line. I'm going to go up here and then down there. And for now, I'll dimension this line to be, let's go 0.275. I kind of like the length that it's approaching now. And then I'll do 0.275 divided by 2. There we go. So these 2 points are going to be important. Hi, welcome back. Slight difficulties. And anyways, we're going to be continuing with the whole. So at this point, you should have the sketch. You should have these 2 points. I believe that's where it started getting kind of weird. Anyways, whole. You're going to click on that and notice you can do simple counterbore countersink. And notice you can say through blind or blind and left. We're going to be starting with a blind hole, tapped M1, 0.25 millimeters. In an earlier take, I had it at M2. I'm too big, so I'm just going to cut to the chase. And let's go 0.125 inch. Let's go, yeah, 0.125, let's say. And let's place it on these 2 holes. Now, pay attention to your merge scope. We do want to go through the fish body here, but maybe in the future, we don't want to go through fish body. All right, and now we're going to make another set of holes. Again, 0.1, 0.2, and let us make it clearance. And yeah, notice to go through fish bracket. Nice. Oh, and you might get this warning. I'm just going to ignore it. Yeah. So you'll notice that the holes don't go on the other side as well. That's because we did not make it a clearance or on the through hole. So we're going to mirror that feature. Now, here's an interesting quirk. You can mirror a part, a face, or a feature. I'm going to mirror a feature. And I'm going to mirror hole 1 specifically. Now, because hole 1 is reliant on sketch 12, you have to mirror that one as well. Now we're going to select our mirror plane, which is this big front plane. We're going to rotate to confirm. We're going to zoom in to confirm. We've confirmed, hit the check mark. And one more thing, now that we've created our holes, we can actually go over to this new tab right here, the hole table, and it'll tell us how many holes and at what call out on what part we have. That's really cool. And I think it's a good way for us to know in advance what kind of bolts we're going to be dealing with here. So another thing we can do is start to assess our mass properties. So let's actually select a material for this fish. Let's right-click fish bracket, assign material, and there is the Onshape material library. I am sure you can add your own as well if you wanted to, but for now, Onshape material library should be sufficient for our needs. And let's go down through all these materials. Look, there's ABS, there's acetyl, there's aluminum, there's Babbitt, there's bass. Okay, we're making a fish. I think we have to select basswood. So we've selected basswood, and you can check the density here, or you can make your own name and density material. Let's say you're using a very specific alloy. Anyways, we now have this part, so we can select fish bracket, and we can click on display mass properties, and everything is there. How wonderful. So ideally, when the students are building their robot, we can at least assess early on what the mass properties are, and we can do that if they add all their fasteners. But tomorrow, you're not really expecting them to add all their fasteners, are you? Well, frankly, no. But, there's the option to do that. So we're going to explore how that can be done. So let's create, I'm going to do that a lot. Let's create a new assembly. Create assembly. Look, it's a blank assembly. And you have lots of new features over here too. You've got the BOM table. You can add columns to that, and we'll do that later. You have your configuration panel if you want to configure the assembly specifically. You have exploded views, which again might be useful later, and MKCad inserter. So if you noticed Dean's message in Slack, you'll know that the MKCad is this library created for Onshape by first students to create, establish some Onshape native parts and make sure that there's nothing that translated over oddly. Ask any of the students who took the advanced CAD, if you import things, it's going to import really weirdly. And the nice thing about this is you don't have to worry about finding the exactly correct model for you, because let's go to gearboxes. If it says configurable, you can actually insert the exact configuration you want into your CAD. And later on, if you want, you can probably insert the cost through the BOM, but as Aiden mentioned earlier, that's going to be more important for our personal organization and for the school than it will be for for first. And it's also worth noting that if we make a purchase, we'll have the receipt. So any big name items we will have evidence for. Anyways, you could add fasteners through here, but you can also add them through insert in standard content, which we're going to do later. So I'm going to start by adding a fish body. Now, be careful when you hit escape. Now, one thing I do want to highlight is this fish body can still move in space. Normally in SolidWorks and other programs, this first part immediately becomes fixed. That is not the case in Onshape, so we're going to fix it now. So I'm going to do something that might be a little controversial. I'm going to use a fastened mate. The reason I'm doing it for the fish body is because I am mating everything relative to this body. And this body is going to be what defines the position of everything else in space. So I feel comfortable mating this. So as you can see, you're dealing with mate connectors here. It's a little bit wonky, I will admit. As a matter of fact, I'm going to hide the fish body for this part. I'm going to rotate a little bit. And I'm going to select that. I'm going to go back to my isometric view, turn that back on. And I'll select the rough metal and click on the check. So, before I click the check, I'm going to show you the reason this is so contentious for a lot of us is because those of us who worked with the CAD students last season know that this specific mate type became the most frequently used mate type. And I think you can understand why that might be a problem. Because this is a rigid, fixed, offset is controlled, position is controlled, angle is controlled type of mate, this has very strong abusing power. Because it doesn't just act as a coincident mate. That's a misunderstanding. This fixes it. This is not going to move. So if you have students use too many of these mates, then you're going to end up with things overdefined. So be very careful about when these are used and make sure that students are doing the long way of things if that is what it takes to avoid using too many fastened mates. All right, so now we can start adding other parts. I'm going to start by adding the fish. So notice, so we have fish bracket right here. I'm going to click and add that. And I'm going to add the fish eye as well. So I will say this, I have had weird issues duplicating parts that already have mates. So I'm not going to go over that here. I'll see if I can figure out how to do that and get back to you. But so what we're going to do is we're going to start by mating this. And let's use some of the more typical mates that we might have students use. We can have a planar mate, which kind of acts as, a plane-to-plane coincident mate. And we'll have it between the fish bracket and this part of the fish body. So it normally snaps center to center, but that's generally not what's happening. So now we can get out of planar. And you see, you can still move this around. It's just going to be like a planar coincident mate. So now we need to make sure that these holes are concentric with each other. So what we're going to do is use this cylindrical mate. Be careful, that's not the same thing as these two, a cylindrical mate. And I'm going to select the center of this hole. Notice that I can select the front, center, or back of the hole. I'm going to stick with the center for now. Mentors with more Onshape experience might say this is a downfall. I don't really know yet, if I'm being honest. Correct me if this is a bad thing. If this is a bad thing, I'm very sorry. And I'll click the check mark. Now, this can technically still rotate, as you can see here. So we're going to do one more cylindrical. So we'll do, again here, and we'll just sort of go there, and there we go, nice and cylindrical. So as you can imagine, if we did fixed, they're gonna, actually, let me show you what happens if you do fastened. If you wanted to do a fastened, then you would have had to define the offsets and you would have had to define the rotation. So I would actually argue doing these three mates is a little bit easier than doing a fastened mate. So now we also need to add the eye. So we're going to do the same thing we did before, planar mate. And we're going to sort of rotate here and we're going to this is a little too close. I'm going to move this guy out and I'm going to zoom in like that. Okay, so we're going to go planar, this face, and this part of the fish. And then we're going to do, and also you can drop down over here and say cylindrical, the circle part of there and the circle part of here. And those are going to be cylindrical with each other. All right, but I can already hear you saying, okay, that's all nice, but you need to fasten this. I thought you were making a big deal about fasteners, weren't you, Tamara? Where's the fasteners? Okay, so we're going to insert and we're going to go to standard content. Now, standard content is nice because you have, again, whatever convention you need. You have pins and studs, bolts, keys, nuts, retaining rings, washers. So yes, we can theoretically add all of our fasteners and all of our nuts and whatever else is needed to this. Again, not sure how much I recommend it. I feel like eventually Onshape is going to get to a point where it's lagging because it's having you load a lot, kind of like how Google can get overwhelmed by people on a document. But yeah, let's go ahead and say bolts and screws. Now, I'm not entirely sure if our M2 is going to be on there, especially because it's an ISO, not ANSI. And yeah, M1 is not on there. I do not blame it. And yeah, let's see if we can find like a little baby slotted head screw, perhaps. Yeah, no, it's just not on there, I think. I do not quite feel like going all the way through this to find something that is M1 with the exact length we need. So let's just put in some M1.6s. Is that acceptable? It's acceptable now. It's acceptable because I say so. So we're gonna drag and notice it can kind of snap, right? It can kind of snap to whatever hole that you're trying to put it to. So if we put it there, oh, that's a big, oh yeah, that's the wrong size. It's okay. This is a training exercise. And part of the training exercise lesson is, oh, it went the wrong way. Whoops. We can fix it. And we're going to insert another one. And we're going to make sure that it actually goes in the right way this time. Yep, there we go. Let me see if I can move that away. Yes, I can. Nice. So we're going to go ahead and we're going to, oh, nice. There's even a mate connector on there. So planar mate. And we're going to do there to that. And you can reverse it, as you always do, as that. All right, so you can probably still rotate it in that hole or move it. Yeah, we should probably not do that. Okay, so cylindrical mate, and we're going to go in there, and we're going to go in here, and that's mate. So I'm not going to demonstrate that too many times. Like, we're not going to mate every single one of these parts together. The main idea I want to show you is what other mates are up here. Speaking of other mates up there, I'm going to have us start doing some mechanical mates. Oh, and I'm also going to move some of these to a folder because this is going to get convoluted very quickly if we don't know what we're having this do. Oh, are we not allowed to put these under a, yeah, I guess not. Odd. I figured we'd be allowed to do that, but it seems not the case. I think it's because it also selects these. I was going to try to have you move into a folder. That's okay. We're going to get kind of convoluted here. All right, so I'm going to show you a rather interesting mate. I'm going to do a slider mate, and we're going to insert the fish tongue to do that. So this is a fish tongue that sits inside the fish. And we're going to add a slider mate so that it just sort of wiggles its way out and back in. So for starters, I am actually going to have a planar mate with the top. Actually, no, let's do the slider mate first. So we're going to say slider mate. Now it looks like it's with a cylindrical surface. It doesn't have to be. So I am going to go in there and I'm going to select this back face. Now I'm going to hide the fish body again. I'm going to go around and I'm going to select this back face of the tongue. Now, the thing about a slider mate is this means it can kind of move forward and backwards. So limits. Now, let's see where the z-axis is going here, because I'm rather worried that this is not going to go the direction we think it is. So I'm going to start off by saying 1.5, oh, sorry, 0 and 1.5. I only want it to stick out about 1.5 inches. And let's animate that to make sure that it's going the right way. Ah, it's not, it's going backwards. So I'm gonna have to say negative 1.5 and 0. So I'm guessing that for Onshape, the order in which you click things matters. Let's put that to the test, actually. Okay, so maybe not for this mate. But yeah, now if I unclick the fish body, I should be able to just sort of pull the tongue out and in. Yikes. Yeah, so this is a little bit of a frightening Christmas present for your kids. But yeah, now the tongue of your catfish can kind of slide its way out. If you look at regular catfishes, you'll notice that they kind of have this look of sticking its tongue out at you and just sort of being there for a good time, but for a very short time since it's out of water and in a human's hand. But that's besides the point. Right now, the point is we need to add the fins. So we're going to go back to insert. And this time we're going to add the back fin. And let's also add a top fin. And we'll add a bottom fin in a bit. So for this back fin right here, we're going to actually do a revolute mate. So I'm going to show you how to do that. I'm going to say revolute. Oh, by the way, as a pointer about this mate, the revolute mate can in many ways function very similarly to a fastened mate in which it fixes things. So I would only use this mate if you want something to rotate. So be careful about that. So I'm going to go to this hole, or I'm going to start with this cylinder. Yeah, let's do that. And I'm going to go to this hole. I'm going to try to get inside the hole. All right. Catfishes are a labor of love, aren't they? All right, so now you should have this little fin sticking out of the back end of your fish. And you should be able to just sort of, do what fin things do, but a little too much, or a lot too much, depending on your definition. And we can actually limit this. And we can just right click on here and we can say edit, and we can add limits. So I'm going to add a limit of -30 and 30. So now if we animate that, so it's still doing a little bit more than your standard catfish is supposed to be capable of, but you know what? This is not your standard catfish. Your mentors, you know this isn't a standard catfish. I'm sorry, it's been a long day. Anyways, I'm hitting the check mark, and we're gonna do that over here as well. We're gonna create a revolute mate. Now, in this case, I need to pull the fin up a little bit. That's a rather bizarrely positioned fin. So I am going to say revolute. Let's go with the center, and let's actually go with the top. Okay, so let's make sure that that's the good position. Yes, it is. I like this position of the fin. And notice I can't drag it up and down. I can only drag it this way and that way. I'm going to Control Z. Yeah, that's the orientation I want. Now, I have two revolute mates, and you're probably thinking, Tamara, this doesn't need to rotate here. But let's say the steering is operated by gears and that it somehow has some sort of connection to the back fin. That's not how it works. This is mostly for propulsion and this is for steering. But let's say this isn't a normal fish. Otherwise, we wouldn't have caught it and put it onto Onshape. I'm going to click on this gear relation, and I'm going to be selecting specifically revolute mates. So I'll select this one and this one. And let's put in a ratio of 2. That way it's very obvious. And remember, this one's limited, so this should be limited too. Yep. And notice that this one is moving 30, but this one does not seem to be moving 30 along with it. It seems to be moving, let's look from the top. So if this is 30, this seems to be 60. That's 60. Now, I was alluding to order earlier. So I'm going to go to gear 1 and I'm going to say edit. What if I reorder it? What if I had it as revolute 2, but also revolute 1? Let's see what happens then. Look at that. That is now 30 degrees and that's now 15 degrees. So when you're doing gear, the order in which you select your revolute mates does matter, and you need to be very careful with it. So now I'm going to do this bottom fin right here, and then we'll be done with our assembly. So bear with me here. You're doing really good, and I'm proud of you. So you're going to go right over here. We're going to go to that middle, just like we did earlier. And then we're going to click there, and we're going to reverse that direction. And yeah, I like this. I like this a lot. But I really want to see if we can link these mates. because these two are going to be moving in unison, but we don't really need to add a gearing to it, you know? So I'm going to see if I can find the button that links mates again, because I remember there was a button for it and I'm forgetting where it was. I believe it's linear relation. Let's see. So Revolut 2, Revolut 1, sorry, Revolut 3. And let's see it go in action now. Let's see if this worked. It did not, it would seem. But I have been able to use linear relations for slider mates. So maybe for this one, because it's an angular thing, it can't really do that. But you know what? We are all learning here, and I am learning here as well. So this is a lesson I have learned. It's a good lesson, I would say. Now let's look at that bomb. You'll notice that it generated everything, and it also generated descriptions, quantity, part number. We can add columns here for name, which I strongly urge us to do, because let's be real here, students are not going to be referring to things colloquially by part number, as they should not be. That's weird. We can also do unit of measure. We can do project, appearance, if we want. So we will have to generate the cost ourselves, but that's literally just an export to Sheets and we're good. Oh, also you can exclude things from the BOM, and that's something that might be useful for fasteners at least. But if we're handing this BOM to the school, then fasteners would be part of our cost. So yeah, and if we had all of our masses in, we could use this mass properties to figure out the center of gravity. So for now, I'm going to slow things down a little bit, and I'm going to take you through the drawings. We're in the home stretch, y'all. We're doing good. I'm really proud of all of you. All right, let's just stick with our normal ANSI. You know, I complain the most on the team about ANSI and, you know, inches and stuff, and here I am using it. I am very deeply sorry to all of you. So let's stick with the fish bracket. So the nice thing is that you just plop it in, and sometimes it automatically tries to do the projected view for you, and that's pretty nice because, you know, projected views are always good for, well, for more complicated parts than this, but it's just a good practice to get into, I think. Maybe I'm projecting too much. Anyways, you know, your normal sheet stuff. You can add the titles. You can say who drew it, who checked it, who approved it, what date, surface finish. Should we start doing surface? No, I'm getting sidetracked again. I'm sorry. We could do tolerance. I'm getting sidetracked. I feel like that's a discussion that goes beyond the scope of this lesson. I do that a lot, and I'm very deeply sorry. But anyways, I hope you notice that you can say projected view and that you can say insert view, which takes you to the part that you're dealing with. You can also click on insert if you, for whatever reason, want to add another thing. I would say it might be useful for you to add the entire part studio, or probably the entire assembly, just so that you have some sort of context. Another thing you may consider adding is a BOM table, especially for drawings of assemblies. Again, at this point, I know I'm preaching to the choir. All of you have been in the industry far longer than I have. I am baby. You guys were in the industry before I was even learning math, before I was even born, some of you maybe. Not that you're old. Okay, I'm sidetracked. This has been going on for a while. Anyways, you know, your detailed view, your broken out section, your crops, all of them are here. And I'm going to show you something in the dimensioning. So you can click here, make your dimension, and then you can click on this little toolbar over here to call out what level of precision you want, how many part number decimals, which if any non-technical mentors are watching, this will determine your level of tolerance as per the bottom of the sheet. You can also use the symbols, and I'm going to hit enter for now. Yeah, no, just, this is good. This is good. This is, yeah, for any notes that you have. Now you can also add hole callouts, which I encourage you to do for these holes right here. So yeah, you'll have your hole callout for what size this is. Sometimes I like to tell students that if they're doing a hole size for a specific bolt, then they may also want to state what that bolt is. But that's especially more common with tapped holes and with like when you're dealing with like a specific fit, and this is not. You can add notes over here. You can add geometric tolerancing. You can add crosshairs, I believe, somewhere. Yeah. So there's a lot of different things you can, oh, it's right here. I'm silly. Yeah, so you can add center marks right here, which is really good for doing center lines if you want to get around having to say exactly that this is center. Is there anything else that might be useful for all of us? Well, I think we can make our own templates of this. And I think we could add like some sort of Jankster logo to the bottom. That might be kind of nice to show the judges. Oh, and one very key thing, we can have version creation and version management and history. And this can show a lot of the different changes made to the assemblies, to the drawings, et cetera, et cetera. I probably should have been making versions as I go. I'm lazy and I'm very sorry. I'll probably end up doing several takes of this. But for now, I think that's a pretty basic overview. I don't think I need to remind us that organization is really important. So we should probably be creating folders as we go. We can probably create material libraries if we want to limit the number of things that our students might be clicking through and selecting. And we definitely need to talk about some of our standards in terms of naming, in terms of any part number convention or naming convention we want to use, in terms of what we're expecting from drawings, in terms of what tolerances we can handle, especially because we now have mills and lathes. And I am probably not the best person to be leading this conversation. Again, there are significantly more experienced mentors, but I think it would be good to like at least start thinking about these things. And perhaps also work with some of our outgoing seniors because they are definitely aware that naming is an issue. I always say I've seen things, and I can only imagine what the more experienced mentors watching this might have seen. Probably a lot worse. And a lot of it might have also been from me since I was a student once. So yeah, that's my video. If there's any additional features you want me to go through, do let me know. If I got a little too jokey at the end, again, I'm sorry. And I will be adding more to this or listening to any feedback you have. If you did not like any of this, please let me know because I don't do this very often. But yeah, thank you. And I hope this was helpful. All right.